In this video, I'm going to start by going through how to use Microsoft Excel to perform a skewness and kurtosis analysis of raw data. And in this first part, I'm going to set up the conditions here or the calculations in order to carry out the skewness and kurtosis calculations. In doing so, we'll be using the classical formulas here for gamma 1, which is the measure for skewness, and gamma 2, which is the measure for kurtosis, and then we will calculate the standard error for each of the two measures respectively using these two classic equations. So the first step here, by looking at our data here, which tracks the NBA salary of the players on the Atlanta Hawks, and these data were obtained from 2015. And the first step is to calculate descriptive statistics for this entire sample of data. And I'm going to use the Excel command of average. So I'm going to hit the equal sign, and I'm just going to type average and shift 9, and I'm just going to highlight the cells over which I want the average calculated. And I shift 0 to close the parenthesis. I hit enter, and we see we have an average salary of $5.1 million for the 14 players on the Atlanta Hawks in 2015. The next important statistic to calculate is the standard deviation. So I'm going to do that as I did with average. I'm going to hit the equal sign, and I'm going to type in the Excel command STDEV, open parenthesis, and I'm going to highlight the same data, making sure I don't overlap with the mean. I shift 0, I hit enter, and we see we have a rather large standard deviation here, and that reflects the fact that we have one player at the very high end at $18.7 million and another player at just over $500,000. But the next step now is to calculate the z-value. So we're going to convert each raw value to its corresponding z-value. And I'm going to type that equation here in this cell for this first person, Paul Millsap. So I'm going to hit the equal sign, and I'm going to shift 9. And I want to calculate the difference between this raw score for this first person and the average, which is located in cell C16. So I'm just going to highlight this cell, and I'm going to subtract the value in cell C16 where the mean is. But since I'm going to use the click and drag option to calculate the rest of the z-values, I have to use the dollar sign. So shift 4, and which locks in the cell, in this case the column of C, and then I'm going to shift 4 for the dollar sign, and that's going to lock in row 16. Then I close parenthesis, and I'm going to divide that quantity by the value inside the standard deviation cell, and I need to lock that value in as well. So I'm going to shift 4 for the dollar sign, and in column C once again I'm going to shift 4 once again because I want to lock in the row for that, and that's row 17. And I hit enter, and now I've converted this raw salary value to its corresponding z-value. So with respect to the average, so we see the average salary is $5.1 million. This first player here's salary was $18.7 million. The z-value would put this player here, Paul Millsap, 2.56 standard deviations away from the average in the positive direction. And that reflects the fact that this person's salary is so much larger than the average. So now I need to convert the rest of the raw data to z-values, and I'm going to use the click and drag option. So I'm going to hover my cursor over the bottom right hand corner until it changes to a thin plus sign. I'm going to click the left mouse button, I'm going to drag it all the way down, and now I have z-values for each of the corresponding raw values. And to double check, I'm just going to click on the last cell. I'm going to go up to the formula bar here just to make sure that I'm looking at C15 and I've got the right cell number in there, and the dollar signs locked in the cell value for C16, which is the average, and C17, which is the standard deviation. And in the next video, we're going to take the next few steps on our way to calculating the skewness and kurtosis for the distribution of these data.